Hello my dear students, today let us discuss about presentation of rainfall data. There are three methods of presentation of rainfall data collected through measurements at a given station. The first method is hydrograph method, second one is mass curve of rainfall method, and third one is point rainfall method. So these three methods are used for the presentation of rainfall data which is collected through the measurements at a given station. Now let us see what is this hydrograph method. Here, this is a graph between the time versus rainfall intensity. Time is in hours and rainfall intensity is in millimeter per hour. A hydrograph is a bar graph showing the intensity of rainfall against the time. A hydrograph can be prepared either from the mass curve of rainfall or directly from the data obtained from automatic rain gauges. Okay, I'll tell you what about this mass curve of rainfall in the next slide. So, this hydrograph can be prepared either from the mass curve of the rainfall or directly from the data obtained through the automatic rain gauges. It is very convenient way of representing the characteristic of a storm and is particularly important in the development of a design storms to predict extreme floods. The area under a hydrograph represents the total precipitation received in that period. It is mainly used to find the precipitation of the particular area at a given time. So, it is the bar chart drawn between the intensity of rainfall and the time. So, this rainfall is either obtained from the mass curve of the rainfall or can be obtained from the automatic rain gauges. It is very convenient method of the representing the characteristic of a storm. This is about hydrograph method. Let us see the second one, the mass curve of a rainfall. The mass curve of a rainfall is a plot of the accumulated precipitation against time plotted in chronological order. Records of flow type and vein bucket type gauges are of this form. I have told in the last class there are different types of rain gauges. So among that, flow type and vein bucket types also the one. So which are used. They uses this mass curve method. A typical mass curve of rainfall at a station during the storm is shown in figure that I'll show you. The mass curves of a rainfall are very useful in extracting the information on the duration and magnitude of the storm. So these mass curves are useful to get the information related to the duration and magnitude of the storm. Also, it can be used for the intensities at various time intervals in a storm by the slope of the curve. For non-recording rain gauges, mass curves are prepared from the knowledge of the approximate beginning and end of the storm and by using the mass curve of adjacent recording gauge station as a guide. So, in the case of non-recording gauges, these mass curves are prepared by using the information about the approximate beginning and end of the storm and also by using the mass curve of adjacent recording gauge stations as a guide. You can see here this is a mass curve. It is drawn between the time and cumulative rainfall that is in centimeter and this is in minutes. Okay, so 5 minutes, 15 minutes, 25 minutes. What is the rainfall? You can see here this is 1.43 here and the same thing here it is about 4.03. 7.02, 8.75 and here like this I have to draw the mass curve and by using this slope you will get the information about the duration, magnitude and intensity of a particular storm. It is mainly drawn between the time versus the cumulative rainfall. So this is also same slope you can calculate at the particular time or duration what is the intensity or magnitude of the storm by using this slope. This is about mass curve method. The last method is point rainfall method. This data can be presented as daily, weekly, monthly, seasonal or annual values. Okay, point precipitation data are used collectively to estimate the areal variability of rainfall. This is about point rainfall method. Now let us discuss about the stream flow measurement. What is the stream flow measurement? As we know that the precipitation, evaporation and evapotranspiration are all difficult to measure exactly, but the stream flow is the only part of the hydrological cycle that can be measured accurately. Okay? A stream is defined as a flow channel into which the surface runoff from specified basin drains. Okay, it is a flow channel into which the surface runoff from the specified basin drains. Stream flow is measured in units of discharge, that is meter cube per second. There are different characterization of stream flow measurement that is mainly categorized under two categories. The first one is direct determination of discharge and second one is indirect determination of discharge. Let us see what is this direct method. So direct determination of stream discharge measurement includes, there are four methods. The first one is area velocity method, dilution techniques and electromagnetic method and ultrasonic method. So these methods are used to find the these are the direct methods for the determination of storm discharge. Okay, indirect method, mainly there are two types, hydraulic structures and the slope area method. Let us discuss one by one. The first one is under direct method, area velocity method. In this type, this method of discharge measurement consists essentially of the area of cross section of the river at a selected section called the gauging site and measuring the velocity of flow through the cross-sectional area. Okay. Here it consists of the area of the cross-section of the river at a selected location. Okay. That is called the gauging site and measuring the velocity of flow through the cross-sectional area. The gauging site must be selected with care to ensure that the stage discharge curve is reasonably constant over a long period, over a few years. Okay, while selecting the gauge site, you have to ensure that the stage discharge curve is reasonably constant over a long period, over a few years. For this, the following criteria are adopted. The first one is stream should have a well-defined cross-section which does not change in various seasons. It should be easily accessible all through the year. The site should be in straight, stable reach. The gauging site should be free from backwater effects in the channel. So while selecting the gauging sites, you have to follow these criteria. That is, the first one is the stream should have a well-defined cross-section which does not change in the various season. It should be easily accessible all through the year. The site should be in straight, stable reach. The gauging site should be free from backwater effects in the channel. The second one is dilution technique. It is also known as a chemical method. Depends on the continuity principle. This principle is applied to a tracer which is allowed to mix completely with the flow. There are two methods of dilution techniques. The first one is sudden injection method. It's also called as a gulp or integration method. Second one is constant rate injection method or plate tube gauging method. Okay, dilution method of gauging is based on the assumption of steady flow. You must have studied all these things in your lower semester under the chapter fluid mechanics. If the flow is unsteady and the flow changes appreciably during gauging, there will be a change in the storage volume in the reach and steady state continuity equation is not varied. Okay, here this method is also called as a chemical method. Here this is mainly based on the continuity principle. Here there are two methods of dilution technique. The first one is sudden injection method, means that chemicals are applied to that flow suddenly, and second one is at a time, but second one is constant rate injection method. The chemicals are injected to the river in a constant rate, means at a particular time some amount of the chemicals are added to the flow. Okay, this is mainly based on the steady flow principle, and here there will be change in the storage volume in the reach, and the steady state continuity equation is not valid. The dilution method has the major disadvantage that the discharge is estimated directly in an absolute way. It is particularly attractive for small streams such as mountainous rivers. It can be used occasionally for checking the calibration, stage discharge, curves, etc. obtained by other methods. And this is about the first method. Second one is ultrasonic method. This is essentially an area velocity method, and the average velocity is only measured using ultrasonic signals. Okay, the second one is, these are the two main methods, that's why I focused on ultrasonic method and dilution techniques, and one more is area velocity method. Next is indirect method. Here this category include those methods which make use of the relationship between the flow discharge and the depths at specified locations. There are two main categories under this method. The first one is flow measuring structures, and second one is, that is nothing but hydraulic structures, and second one is slope area method. Let us see some details about flow measuring structures. Structures like notches, weir, flumes, and sluice gates. For low measurements in the hydraulic structures, hydraulic laboratories are well known. All of you know how to find the velocity of the notches, weir, flumes. You have used in FM lab. These conventional structures are used in the field conditions, but their use is limited by the ranges of head, debris, or sediment load of the stream and the backward water effects produced by the streams. The basic principle governing the use of this structure is that this structure produces a unique control section in the flow. At this structure, the discharge Q is the function of the water surface elevation measured from the specified datum. That is, Q is a function of H. Q is discharge and it is a function of head, where H is water surface elevation measured from the specified datum. There are different categories of hydraulic structures. The first one is thin plate structures. Second one is long base weirs, that is broad crested structures. And the third one is flumes. This is made up of concrete, masonry, or metal sheets. Then second method is the slope area method. This is here Manning's formula is used to relate depth at either section with the discharge. Knowing the water surface elevation at the two sections, it is required to estimate the discharge. Okay, here using the two sections, discharge can be calculated, and the energy equation is used to find that discharge. So this is the energy equation. Z1 is Z1 plus Y1 is plus V1 square divided by 2G is equal to Z2 plus Y2 plus V2 square divided by 2G plus HL. This you have studied in fluid mechanics. So when you simplify this, you can calculate the head. Okay, so this is about the stream flow measurements. I hope all of you understood. Thank you.